Hello and welcome to this introduction video about recurrent neural networks. So we're not only going to discuss recurrent neural networks, or RNNs for short, we're also going to discuss a variant of RNNs, which is basically called long short-term memory, or LSTMs for short. So let's start. First of all, why do we need RNNs? What's the real secret behind RNNs? So basically, RNNs, they're used for time series analysis. When we want to make predictions based on previous data, not only the current data, then we need to use RNNs. So basically, they make use of sequential information. So another way to think about RNNs is that they have memory. Okay, so they record memory on what happened previously. They capture this memory and they make the prediction based on this memory. So let me give you two examples of when we're using RNNs. So stock price prediction, right? So when we want to predict the stock price, we can't just look at the current input. So for example, the current input might be the previous day. So in order to predict the stock price, we can't just look at the previous day to predict it, okay? We need to look at previous months or sometimes previous years, okay? So they're all sequential information, and you're going to need to analyze all of them in order to make the prediction, okay? So you're not only relying on one input, the current input, which is, for example, the previous day, okay? Or for example, let's say the previous week, okay? You can't make stock prediction based on this input only. You need to remember what happened previously. You need to analyze what happened previously, and based on this previous information, this previous sequential information, then we only make a prediction. So another example is text generation, okay? Let's say we want to predict the word her, okay? So we have the sentence, she spoke to her husband, and we want to predict the word her. This is our objective. Our objective is to predict the next word based on the given current word. So we're going to give the network the word to, and we want it to predict her. But realize that if you only rely on the previous word, which is to, then you won't get this word correct. You won't get this prediction correct. Why? Because her is dependent on she, right? Since this is a female, okay, then this network will learn that after to should probably be her. So the network needs to remember, it needs to have memory on what happened previously. Okay, so you need to analyze the previous words in order to predict this word. Okay, so that's where you use RNNs. Now, another way to think about RNNs is memory. So I said this before. So RNNs are basically memory networks, and they capture information about what has been calculated so far. So at the end of this video, we're actually going to walk through a practical example. Okay, so we're going to walk through a step-by-step example, and you'll get a more clear understanding of what RNNs really do. All right. So let's jump to the next slide and see what RNNs really are. Okay. So RNNs are just multiple copies of the same network. Okay, so you repeat the same network several times. Now, each time you repeat this network, then this network receives a different input and the previous hidden state. So this whole thing is a neural network with these input neurons and these hidden neurons. Now, the output of the hidden neurons are passed to the next neural network. So this next neural network receives the outputs of the previous hidden neurons and the next input. Okay, so these whole things are called time steps. Now, time steps are how many times you copy this network, and this might depend on your problem. For example, here, if we're using this sentence in an LSTM or an RNN, she spoke to her husband, then you're going to need 5 time steps. In other words, you're going to need to copy the network 5 times. She spoke to her husband. Okay? Each one receives this input. So she spoke to her husband. Okay? And it passes the hidden states, or the output of the hidden neurons, to the next neural network. So no worries if you still don't understand what's really happening here. Okay, there's still a lot of diagrams coming, a lot of visualization coming, and hopefully you'll have a better understanding after we go through them. Okay, but here I'm just introducing you to the general concept only. Okay, so let's see the relationship between RNNs and normal neural networks, normal feed-forward neural networks. So you have this neural network over here. Okay, it's a very simple neural network. You have an input layer, a hidden layer, and an output layer. Okay, so here you have 4 input neurons, here you have 3 hidden neurons, and you have 2 output neurons. So this is just a very simple neural network with fully connected layers. Okay, 3 layers only. Input layer, hidden layer, output layer. Now, what we're going to do is we're going to take this neural network and we're going to flip it. Okay, so take this whole thing. This is just for visualization of an RNN. Okay, this is what I want you to get. I want you to visualize the normal neural network and the recurrent neural network, the relationship. So if you take this and you flip it, then this is what you get, right? Now, what we're going to do is we're going to pack this whole thing up. Okay, so we're going to represent it as a multi-dimension. So let's go ahead and pack this whole thing up. This is what we get. So we have 4 dimensions. Okay, here we have 3 dimensions, here we have 2 dimensions. So what we did is we just packed this whole thing up. Now, what we're going to do is we're just going to represent the multi-dimension neurons as one neuron. Alright, this is just for visualization purposes. So, this is what we get. So this thing over here is a multi-dimension. Alright, remember it has 4 neurons, but we just represented it as one neuron. Why I'm doing this is because later on you're going to see the representation of RNNs as this shape over here. But you shouldn't be confused and think that this is only one neuron. Actually, this is a multi-dimension. You have here 4 neurons, and here you have 3 neurons, and here you have 2 neurons. Okay, so then what we're going to do is we're going to take this RNN over here, which is basically a neural network, okay, which is this neural network, and we're going to copy it for how many time steps do we want. So for example, if we're going to use 5 time steps, then we're going to copy it for 5 times. Okay, so this is what we get. The same network copied for 5 times, and each time is called a time step. So at each time it receives a different input and the previous hidden state. So each one of these is just a neural network, which is this neural network over here. Alright? So it's just a multiple copy of this neural network. So each one of these receives a different input at every time step, as well as the previous hidden state. So for example, this neural network receives this input over here, and the hidden state for the previous neural network. Okay? This one receives this different input and the hidden state for the previous time step. Okay? And so on. So what you're doing is you're passing information from one neural network to another. Or, in other words, from one time step to another. So if we go into depth of this visualization, this is what we have. So this is your first neural network, but here previously we have 5 time steps, but here we only have 3 time steps. Okay, so you have this neural network. These are the hidden units, the RNN hidden units, okay, which are basically the hidden neurons here. So you have this input, okay, and then you pass it through your hidden layer, and the output of this hidden layer gets passed to the next neural network or the next time step. So this neural network receives this previous hidden state and this new input, and so on. Alright, so this whole thing is the same neural network, it just receives different inputs at different times, plus its previous hidden state. So another way to think about it is just a neural network that passes the hidden state information back to itself. Okay, which is what's represented here. So you're processing this hidden states. Okay, you're passing the information to the hidden states, and this output of the hidden state is getting passed back to the neural network. So it's just passing information back to itself. And this is what's happening here. And each time the information is passed back to itself, then you have a new time step. So this is what's really happening here. I hope you got it by now.